I'm George, and just let's start with a presentation. That's a program I have for this for today, and it's a small introduction. And then I try, coming out from my experience, how we design step by step to come to more or less sustainable building. And this I will explain with some examples from my office. It's what is motivating me, why I'm working on this topic. I want to explain here the given framework I find today. And the situation is today, it's an ecological footprint. It says what our world is producing on biocapacity and what we are consuming. And so you see we are already consuming our world. And we have this report, this bookkeeping also for several countries, and the red ones are consuming much more than their country is producing. And it doesn't look very good also for Austria, and it's worldwide. This is a worldwide statistic. It's a bioproductivity and the consumption, because if we consume too much, the production goes down, and it's a critical situation already. This also is valid for Austria. We also have started to consume more than our country is producing. It's even worse in the United Kingdom. It's relatively good in Sweden, because in Sweden your nature is still producing more, but we have to see it worldwide, of course, because worldwide it's a dramatic situation. It's our ecological footprint, and if we go on like this, we would need two worlds, two globes in 2030. Do we have it? And I think you all agree we don't have it. Therefore, we have to try to consume just what one world is producing. The objective behind this is that I have kids, and I have also, they have kids, and I want that they have the possibility to have a good life on this planet. Like it was definite here, that we want to have a nice environment, a nice living for us, and also for our grandchildren and the next generation. And this I try to work on in my office with my project. And it's a statistic from Austria. In Germany it's similar. We have an increasing number of units in the housing field, but the CO2 emission is going down. That says we have some success. It's not yet what we need, because we have to stop the CO2 emissions, but you see that it's quite successful. How can we do it in housing? How do we do it in Germany and in Austria? And what does this mean in architecture? Because I am in an architecture, and the architectural consequences are important for me. First of all, we have to find an architecture which fits to this kind of new needs. It's an ancient culture in Yucatan, in Mexico, and they believed that the god is a snake which is coming down every year from this pyramid. And he is really coming down with this shadow on the equinox of every year. And this, for me, it's an architecture which fits completely into the view of those ancient people. And we have to find again an architecture which fits to the new view we have about the world. How can we work on it? What does it mean for us? It's my office to introduce myself shortly, waiting for the next contract. I'm also teaching at the Danube University in Krems about solar architecture, where we have a summer school with a lot of Austrian university, a 3-week school where we try to teach this subject. Some buildings, so that it's just images that you see what we are working on. I myself living in this building since 23 years. We made over the time a lot of projects, and I want to give you an image how we are working on it. It's most of it social housing, and one part of it, of course, is heat recovering from ventilation, right? For elderly people, for vacation, one family house. We also do a lot of one family house. Meanwhile, we have built more than 100 projects with this approach. Offices, homes, social housing again. Kindergartens are an important matter for us. Housing, I will explain this project a little bit more in detail. Renovation is a very important topic for our countries where more or less everything is yet built. Or again, renovation, or a straw house. Competitions, some competitions we don't win, like this one, or a recent project where I'm working with families together on this that new project, which is based on favor of bicycling. So now we can can go into the subject, how to design a sustainable project which gives also a future for our followers. How can we do it? And there's a kind of hierarchy behind it. And I want to show it step by step. We have building materials to build the buildings, and we use the building, and within we deal with energy conservation and production, and I will focus a little bit more on some topics which are very important for me in this way of building. If we look to the building, we have the production, the use and the recycling. And we have to look to the whole cycle of the building process. First of all, let's look to the building material to building. It's on the one hand the material, and the other hand the organization of the building site. Because we have diminished very much the energy for running the house. In your climate, and it's this northern or middle Europe climate, it's mainly for heating. And this is the energy in traditional houses for building it. But if we diminish this energy to more or less 10%, what we can do today, then the gray energy built in the products is more or less the same like the energy we need to run the house. And therefore, after being successful in diminishing the consumption, we look more and more to the gray energy we need for building. I use this example because we could do it very consequently in this project. It's a project made out of few very clean, the environment not stressing materials. One material is clay, it's earth. We have an unlimited amount of it. Another one is straw. It's a rest product, a good CO2 storage. And the third is wood for the construction and very small glass and metallic parts for this building. So it's a completely clean building. It's a construction which is thermally separated, wooden piles, straw in it, clay on both sides, earth on both sides of this wall. The wall is prefabricated in the industry because you can work better in the industry. And since to carry products with petrol-driven cars is very bad for the environment, we try to bring the building parts on the rail, which is more environmentally friendly. In this case, we were lucky we had the industry with a rail connection, and also the building site is a side of a railway track. So we could bring all the products directly to the building site, and from the train, the house was built. Also inside all materials, the air ducts for the air, for example, are not metallic. They are made out of clay, which is produced with sun energy. It's sealed, airtight also with clay, and the air, for example, comes out here. These workers have very good working conditions. They are not touching toxic materials, and the client was arguing in this building, the rest in the vacuum cleaner can go to the compost. You don't have to give it to a special depot. It's the inside of the building, and that's what the building looks. It's an office which is producing clay products and colors and natural things. It's in the industry. And now it's a product, it's a prefabricated house. You can buy it in Austria. It's inside of this house and outside of this house, built just with this very clean material. So in respect to material, we have to close two cycles. It goes back to cradle to cradle. It's a special theory that we have through composting one cycle. Also natural things you can compost, and the other is the technical recycling. The technical recycling is like you can recycling a car or metallic things and so on. And if we close these two cycles, if we have a better organization of the building site, we will have much less problems with building. Next, the building itself, running the building. Giving with the building a comfortable climate. And there are two steps. One is energy conservation, that you have a fewer demand, and if you have few demand, you can cover it with solar energy. How does it work? If we take on one line the energy a house is consuming. We started with the building material, it's consuming energy, it gives environmental impact. If we go on running the house for heating, lightening, giving a comfortable climate, this might be building. This is the use of the building. And this might be the recycling. So if we have on the other line here, the energy you have to offer the building to run it. And if we have a zero energy building, we have to compensate the environmental impact of the building. We have to compensate the use of the building and the recycling of the building, and might be also for some traffic. And if this is very high, of course we have a problem to substitute this with alternative. If we make it more intelligent, if we use very few energy for building, if we use more or less close to no energy for running the house, if we have a good way of recycling, and if we use an electric car, we have much less to cover. This means we have to produce much less energy. And if we go with this smaller and smaller, it gets easier and easier to cover the demand of the house without environmentally bad impact. How can we do it in housing? It's a zero line. And we have, if we produce more, we have, in this case, a plus energy house. Which is our subjective, because if we have plus energy house, if we help the environment with our houses, we have much less problems in the future. We can reduce the consumption of energy for running the house, that we have a good volume surface relation. If it's very compact, there is in this cold climate less energy losing. For the house itself, we have the house. a shell, and we are inside, and we are losing energy, of course, because it's cold outside, and we want it warm inside. What we can do, we give a good insulation to the house, because then the energy, the heat cannot escape. We have good energy insulation here. But since we want to see out, we have windows, and we have to make good windows so that we don't lose energy through the windows, not through the building shell. We have to make it airtight so that we don't have uncontrolled air ventilation. And with this and no thermal bridges, we have reduced very much the demand. How could it look like more systematized? It's a building. We give a good insulation on the opaque building parts. We give high quality windows, triple glass, passive house quality, and we have to make very good details so that it's airtight and we don't lose energy. And if we have more or less no losing through the building shell, we still need some energy because this one here, he wants to breathe. And therefore he needs fresh air, and the old air has to go away. And it's a losing of energy for the heating season. And therefore we can make a heat exchanger and control so that he has always the best air to breathe, and we can recover the energy from the old outgoing air. And then we have really minimized the consume of the building, and we can do it by heat recovering. For the summer, we have to care that not too much sun goes into the house, and therefore we have to make sun protectors. In this strategy, which is more or less a passive house strategy, we have come down from old building, from the recent standards, to passive house quality. And this quality concerns heating. But there are other things we are consuming. We need warm water, we need electricity, and we need mobility. And you see, in the beginning, heating was the biggest part. After coming down with heating demand, we have to look to warm water and to electricity. And the house has to be productive. How can we make our houses productive? We can engage different forms of energy which we find on the side. If we take this typical house, this is the solar potential the house has. So we can use passive solar through the windows. We can use active solar to produce warm water for warm water and heating. And we can produce electricity by photovoltaics. And in summer nights, we can do some cooling by natural ventilation. And during daytime in summer, we have to protect the house so that no sun enters into the house to heat it up and make it inconveniently. Let's look to a built-in example. It's repeating the same hierarchy. It's the project we realized. We have a very good insulation all around the building, in this case made out of paper. We have very good windows, triple glassed, a lot of detailing by the architect. It's a lot of work for the architect. And we recover the heat from the used air, transmitting it to the incoming air. How does it work? If we have a good building house, we might have this transmission losing. It's kilowatt hours per square meters per year. And we are losing about 35 kilowatt hours a year per square meters for ventilation. We have some internal production. It's internal heat. It's your cooking, your body is giving heat. And through the south-orientated windows, we have solar energy, and therefore the heating demand is about 40 degrees. If we take recovering for the ventilation, we have heat recovering from the ventilation, and from the 35 kilowatt hours, we regain 27 kilowatt hours, and we have a passive house. And therefore, in respect to heating, we really have come down for the heating demand. So it's this additional solar use. I think it's intelligent to use the sun for running the house, because the resources we are using today, it's like gas, petrol, coal, Iran. We cover this small demand we have worldwide yearly with those resources. The resources are diminishing, and burning those is destroying the environment. Therefore, it's better to use the sun, because the sun is this big cube we have in reserve, and not just one time like those one. It comes every year again. So it seems really better to engage the sun. How can we do it? We can do it in a passive way. It's a very specific architecture. If we design a passive solar-used optimized house, this house looks to the sun, it opens to the sun, it lets in all the sun into the house, because the house is the collector. It's different if we want to produce warm water. It's not the house itself. The house turns its shoulder to the sun, it's close to the south, it looks to the north, the opposite architecture. Or PV, the specific of PV is that it works better if it's cold, it's sensible against shadow, and therefore it should be ventilated. We call it the flying part in the architecture, to bring as many electricity to the house as possible. In this project, we had these 3 different strategies, and we tried, and this is the architect's work today, to combine this on our house. This is the harvesting we could make every year on this house, and it's passive solar use. It's very simple. Sun comes in winter, sun goes up in summer, and cannot enter into the house. So it's cooling in summer, next winter comes, sun gets in, next summer comes, no sun gets in. The sun rays are heating up the building mass, and during night we have some heat in the house. Does it work in this example? It's the theory, but in practice, you see sun is coming in very deeply in this house, heating up the building mass during winter. If we have sun, it's a winter situation, it's a pleasure to have the sun in the house in winter. In summer, it's opposite. All the glasses should be in shadow, and inside we like shadow in summer. We have in this house active thermal collectors, and we have the PV in double function. It also gives shadow. We have the east and west windows have to be closed so that the sun doesn't come in, and during night we need a good ventilation to cool down the house to the night temperature. And the cool ventilation is done if we have openings and we have a distance between going out and coming in air. In this case, we deposit heat we have in summer too much from the thermal collector underground, and we have a heat pump. And this heat pump is optimizing the energy we have on the site with electricity, with optimized electricity. And in this case, the heat pump can serve different resources. It can take out heat from the earth, from the air, or from the collector and the water tank to optimize all those strategies. It's a prefabricated package because plumbers sometimes make errors in installing it, and it can install without errors. Other resources we have on site, like window, for these windmills, like underground or deep drilling geothermal energy. But for me as an architect, it's not just this energy, it's also that I think with those new strategy, we get a better living quality. Why? Because we can have more daylight with the passive solar approach. For example, this house has 60% of floor area with windows. The standard is 10 or 15. It's like what the house looks like. It's light also coming from high up, so we have a lot of daylighting which saves energy and is a living quality. Up from the north and from different sides, it's lighted. We also have to use the resources, the visual resources on the side. For example, this house looks to the Italian mountains. It's a very nice view, and therefore we need this transparency. It's very open to get these resources of thermal connections, this contact to the environment. Building material, it's again wood, clay, and paper in this case. North side, and this transparency gives the house a very special look. You can use this strategy also in bigger houses, like a project we made for Italy. It's the same strategy, it's the same housing type. Or a plus energy house. With this type of house, we can offer about 20 kilometers of mobility, which is additionally produced. It's an overproduction of the house and all the house. Of course, houses will look a little bit different. For me, it's a new kind of architecture. I will touch a little bit more in detail the concerning energy conservation, the controlled air ventilation, and concerning production, these three solar strategies, because they are very important for me. First, energy conservation by controlled air ventilation with heat recovery. But it's not just energy. For me, in the first line, it's a comfort. Because as human beings, we need about 25, 30 cubic meters of air every hour. And we also have to bring away the humidity in housing, because we are taking a bath, we are taking a shower, we are sweating, and therefore we are cooking. A lot of humidity is in the house. And normally we need about 30 cubic meters of fresh air every hour. If you calculate it for a normal house, you would have to open the window every 3 hours to get enough fresh air. When we don't do it, then we have to make it with controlled ventilation. Additionally, we can recover about 80% of the energy which is in the outgoing air in winter. There were made studies in Germany and in Austria, calculated and monitored in schools. In schools, we have a lot of people on few square meters. We have 70 square meters for a family which has 3 heads, 4 with 2 kids. But in the same area in school, we might have 26, 30 students, including the teacher. And of course, they need much more air, because 30 times 26 times 30 cubic meters. And therefore, in schools, if we don't have controlled air ventilation, if we have just window ventilation, we get very bad air, which is very bad for the poor kids. It's here measured one. This is what it should be, and this is what it exceeds. The window opening for during the break doesn't help very much. And it's again measured. And this is what it looks like if we have air ventilation. If we have air ventilation, the students behave much better. They have their head clean for thinking. It's the same in housing. Without ventilation measured, a lot of time, bad air quality, no bad air quality if we have a controlled ventilation. It's an example of a new attic we made in the city of Vienna. It's an air ventilation system. In this case, we had also air ducts in the floor. It's here the detailing of the architect, because outside on the terrace we have a lot of insulation. Therefore, inside the floor is higher. We could go here, and the outlet of the air is in front of this very big screen. It's a very impressive situation because it's in the front of the Cathedral of Vienna, and it's a luxury to open this house, but you have to do it in an environmental safe way. Or in one-family houses, or here we have no heating system. It's a heat pump inside the ventilation system, and therefore it can cover, if we have a passive house standard, all the heating demand. Since we have very big screen here, in the morning the heat load, not the heat demand, can be higher than this 10 watt, which we can cover with air, and therefore they have a small stove. All the air ducts are open, because it's a concept that we should understand how our house is functioning. It's in a kindergarten, also the air ducts visible for the kids, another kindergarten. Or in a home for elderly people, it's a lot of volume, it's 124 people in it, and therefore the heat recovering machine is bigger. Concerning the production, I want to look a little bit more in detail to passive-active solar use. We have spoken already, passive solar use, active thermal use, photovoltaic in its ideal form. We have to combine it, of course. Passive solar use. It's a traditional thing in Spain. In Galicia, in La Coruña, for example, we have all this technology already in the end of the 19th century. There are galleries with glass and heavy stone, which is a good combination for passive solar use. Or more recent houses, or a very simple way, it's winter situation. In this social housing, the air comes in deeply into the house. It's a north facade to heat up the building mass. The sun is far down. It's more down here in Sweden. And it goes up during summer. You see the sun in summer. And therefore, those balconies give shadow completely to the building. So the building is, without moving, in summer in shadow, in winter in the sun, which is good for the housings. It's another project, again, winter and summer situation. A kindergarten, where you can choose how much light you have inside by those screens. Or a vacational area which is used in summer, but sun keeps these houses without freezing for all the winter. Passive houses added to an old building, or this home for elderly people, which has a west facade which is flexible. Winter situation, sun comes in. In summer it can be closed completely. Winter gardens with indirect solar gains. Winter gardens in Salzburg in a bigger project. And air ventilation here functions in that way that air is sucked into the winter garden. The temperature goes up on a low level and goes inside the house preheated. And the heat recovering of the ventilation system gives the heat to the common rooms. It's a social concept. The waste, the rest energy of ventilation is giving to communal rooms which the people have together. Another housing project in Vienna where in all those systems the ventilation is incorporated in these winter gardens to give profit all the house from the gains in the winter garden. It's an office with a communication area where solar energy is gained in this area, where there can be flexible temperatures, where it's nice to sit in the sun for communication, not for working with the computer. The working for the computer is on the north side. Housing project in Vienna, where people can use against the street like in small Italian villages. The sun enters, penetrates the house in winter, stays outside in summer. And that's this gallery where people can enjoy a little bit longer the time outside. And the additional function like drying the clothes in the sun, which is healthier, less destructive for your clothes, and not consuming energy. Or to enjoy this poor sunshine we have during autumn and spring. Active solar use. This house, it has also a system which goes to a storage tank, and then it has to be managed to deliver it. I think it's a very nice architecture. It's mounting it instead of roof tiles or in the facade, optimized for the winter, or in this, it's a office and houses, and they have together a big storage tank here. And of course, they have a lot of overheating during summer, but luckily there is a swimming pool, a public swimming pool close by, and the overproduction in summer is delivered to the swimming pool, so this house is producing more energy than it consumes. This is a project in Salzburg. They are looking to very nice mountains with the passive energy. But here, the poor second floor, he cannot look out into the landscape. But in this case, they have a look to this castle of Salzburg. So it's very important that the strategies are fitting together with the urban design, with the specific resources on this side, which is in this case the view to this very nice castle. The collectors are produced in wood. They are coming here, mounted, and there's not any tile anymore on the roof. It's just thermal collector. This is 430 square meter with a big storage tank. It's a storage tank, so architects again can build towers. It's fine. And the whole development. Or in this renovation project, integrated in the roof, so it's not so visible, with a big storage tank to overcome 1 or 2 weeks with this reserve. Or in a sporting hall for showers and so on, a lot of warm water is needed. Therefore, the tank look comes out from the basement. And on the south side, there's a collector, and from the north side, the light comes into this hall. A kindergarten, separated passive, active use, mounted, substituting the surface, the facade of the building, a lot of carefully done details, and the finished kindergarten. Or in an office. Why is it vertical in an office? It's vertical because it's not needed for warm water. In office, you have no warm water demand. You are not taking showers and baths. You need it for heating. And therefore, it's oriented to the summer sun, which is down. Or another office, again, collector for summer sun. For winter sun, not for summer sun. Nighttime. A home for disabled people, working groups, and also the big tanks. Sometimes you have to care because they are bigger than your basement. Active solar use in a photovoltaic way. We are producing electricity. They have their specific demand. No shadow, good ventilated because they are losing productivity if they get warm. In the opposite to thermal collector, he likes to get warm. There are different technologies which are important already in the first design. It's different technologies producing the same amount of electricity. And you see with these techniques, you need much more square meter than with this technique. And therefore it depends on your design, what technology you should engage. It's again this relation with this monocrystalline, which are very productive, and these amorphous are not so productive, but they are cheaper, and if you have enough space, you can also use them. What very is important is temperature and this orientation to the sun. If you have it 90-degree integrated in the building, you have 1 unit of productivity. If you shift it more to the sun, and if you shift it even better and have a good ventilation, you get 3 times more energy out from the same collector. And I think as architects, we always should use the material in its optimized way and not to waste energy. This project for the city of Vienna, we made a housing project for low-income people. It has also PV here because there's no balcony and we needed some shadow anyway. It's mounting the photovoltaics, connecting them, and you see there would be overheating during summer, and therefore the PV is protecting not in winter, but is protecting in summer. Here you see they don't have overheating because the PV is giving shadow. Or in an office which has a nice view to the outside, the PV gives shadow, and it's a very nice shadow. And different technologies give different shadow, and with this shadow we can work. Shadow is architecture. Shadow moving around the building, moving in the house, we can design it. And it's a pleasure to work with it. For example, this is protecting this PV, the people when there is rain, and when there is sun, it's like a sun deal moving around at different time and giving it a very specific relation to the environment and giving power. Another kindergarten where also the PV is protecting the green and giving a very nice shadow. Moving, we have moving architecture. It's not a static architecture. Or for a project in Italy where we had to protect the windows very carefully against the sunshine. And since the sunshine is high in the south, the screens are like this. In the east and west, they are more down because the sun is not so high up. Or in southern countries where it's very hot, it's for Cyprus a project, PV is not just producing energy, it's also producing shadow, which is a value in a hot climate. A one-family house in Vienna. And it's interesting. Here you can see how much energy you get out from this different strategy. If we have a thermal solar collector, 15 square meters, it's this one here, we get out 6,300 kilowatt hours. We have a PV installation, 61 square meters, we get out the half of it. But it's electricity, a higher level of energy. The air ventilation with heat recovering, it brings us 4,700 kilowatt hour. It's an important point. And we have a earth tube which is collecting heat from underground, it brings 2,000. But it's important in your design that you already know how much can I reach with these different strategies. Sometimes it could be quite funny too to work with this solar use. It's a governmental building and the governor wanted to be a solar governor. And it would have been the best to give it on the roof. But he says nobody will see that I am a solar governor. And therefore, he wanted to have the PV in front of the building. And we suggested it in this way because the house is not oriented completely to the south. And therefore, we oriented in this way the PV so that it's getting the sun in an ideal form. It's letting in during winter the sun and giving shadow during summer to the whole building, which is good for the building itself, and it's a progressive, very dynamic architecture. It would have been a dynamic governor, but they were in fear that it's too dynamic, and we were second place and couldn't realize it. A kindergarten, and you see again this different strategy. Here we have passive solar use. Here we have active solar use For the small kids, they have to wash the pampers and so on. And here we have PV, and PV is protecting in summer the passive solar use. Or we even could make whole cities. It's a project we did in Iran where we have a lot of sun power and could run also touristic development with PV. Or even we go further, not just looking to the single house, with the social together we can reach much more. And this is a suggestion for a whole new city development in Vienna. And it is a place where in former days was gas produced by coal, very toxic. And now there should be new houses, and we suggested that we put on all the houses PV, and with this PV through electrolysis, we could make out of water O2 and H2. And this gas we can mix with city gas, and we can run and warm the city, or we can reproduce electricity out from the gas. So in a bigger range, we have much more potential, because with this system, it will be possible to store the energy from summer to winter, because it's our problem. We have too much sun in summer and not enough in winter. If we find a technology to storage it, especially concerning technology, I think we have gained. And power to gas is one of those technologies, and we try to bring it through in our newer project. Cooling might be it's not so important in our climate or here, but in offices it is, because we give a lot of heat, and if there are a lot of people in schools or in offices, we also in our climate have to do some cooling. We can do this cooling also with heat recovering from the cold air inside the house, cooling the incoming air. But at first we should try to bring down the demand on cooling, then it's easier. And you remember perhaps this passive solar use? This is winter. This is summer. In summer, there is completely shadow in this area so that it doesn't overheat. But it's not enough, because there's still diffuse light. And therefore we have night ventilation. Night ventilation, automaticized, sealed against robbery, and it's in the forests of the Vienna forests, and it gets cold during night, and also building mass is by good ventilation brought down to night temperature. It ventilates through from the deepest point to the highest point, so that the building mass is cooled down. It's the second strategy. There's a third strategy, that the fresh air comes in here, goes under the lake and is cooled down a little bit and goes into the air exchanger, and it's cooling the fresh air for the people inside. And there is even more, we take the underground water, we set more or less the average from outside temperature over the year, might be 15, 60 degrees, and it's cooling down this wall. And therefore it's cooling. And together with also strategy, we are competitive with all these energy consuming old strategies. In this case, we have also the possibility to swim in this lake. It's a firm which are producing natural lakes, and it's a more natural way. Or to use the water from underground. It's in the city from Vienna. And when the concrete was casted, we have given in some tubes, and in the tubes runs the cold water, and it's cooling the building mass. It's these water pipes. And also in the old parts, there is a second ceiling with the cold water inside. Some examples in detail. We have the time still. It's a housing project, a social subsidized housing project. It's a passive house with active elements. But it's not just so strategy. It's also we have a good connection to the public transport. We have green area around, so we can reduce also by urban planning the traffic. It has a good connection to the rapid transport system of Vienna, and we have the same strategy like before in every of those buildings. It's a garage underground, and here we used insulating concrete to avoid thermal breaches. It's a concrete building with a passive house windows with all those detailings. It's airtight. We prove it 2 times. And for example, here it wasn't sufficient sealed in these edges because window and concrete, and it had to be adapted. We have very heavy insulation, up to 40 centimeters in this case. It's on the wall here or on the roof here. So this is my shoe. A lot of detailing. In my belief, also the architect should get a little bit more honorarium for all this work, because all these things have to be detailed. And it's, for example, the fence is fixed here, and all the metallic parts are separated from the concrete to have no thermal breaches. Also, these balconies are separated completely from the building with insulation material here. Or the ducts between outside and inside, they have to be airtight, and you have to avoid thermal breaches. There's a lot of detailing. The ventilation in this system is fresh air comes in here. It goes into the ventilation with heat recovery. It's distributed through the corridor. It's easy to maintain it. Then it's used in the unit. It's sucked away. It goes back to the heat recovering. In the heat recovering, it's cooled down, and the old air goes out here on the side where the street is. It's again the system, the ducts in the stairway, the distribution in a double ceiling, and since we have a passive house with very few energy demand, we can do the heating with this very small heating panel, which is beside of the incoming air, and so far we need no more heating panels inside. The air comes out here, it's the air duct, and here the radiator is mounted. The filters, which of course have exchanged, and they are bringing in a better air than outside. Other resources could be, in this case, we have pipes under the garage, and from this underground during winter we get some heat to protect the ventilation machine against freezing, and it brings in a little bit of cool during summertime, and it's freshening up the incoming air. The thermal collector on the south facade, we didn't know which collector firm would come, a lot of different drawings, but what is important, all these details were done by the architect. You cannot do it just in a standardized way. How is the edge between plaster and between glass? Those things had to be thought out carefully. The piping for these collectors is integrated in the insulation. Here their collectors are mounted and they are fixed. And I think it's very nice because it's mirroring the environment. It's this facade in different situation, it has different colors, and we say we can compete again with the Baroque architects because we have these very nice paintings on our walls. And we are even better than the Baroque architects because these pictures are changing always. And the good ones of you will also see the angels behind these skies. The storage tank, again, it's big, and on the roof we have a PV. It's in this case 100 square meter photovoltaic, and it also gives a special look to the building. Another example is renovation. And here it was very interesting because it's a very good built building. It's rented. It was rented for bureaucrats. It was built very solid. But the problem here was no entrance, no access for disabled people because it's a little bit up on the hill. And everything was done with electricity. The warm water and the heating was done with electricity. And on the floor, there were metallic wires within the concrete in the floor, but they get rotten already and it's very expensive to heat with it. And therefore, at first, the building company thought to install a gas stove, a central one, and install radiators, heating panels in every room. But you can imagine how hard it is in furnished rooms to bring in heating panels with water. It would have been very expensive and it would have been a problem for the inhabitants. So our idea was, forget about this floor heating because they were rotten and we couldn't go on with it. If we make a building shell which is such good that we can heat it with the air, but not with a lot of air, it's just the air we need anyway for our healthiness, 20, 30 cubic meters per hour. And second, the air shouldn't be too hot, not more than 50, 55 degrees to have no uncomfort in it. And with this, you can transport very few air. And this was a basic passive house idea, to heat with air, and the heat load cannot exceed more than 10 watt per square meters. So if we keep the heat demand below 10 watt, we can heat with the air with a very high curve. And therefore, in this case, it was cheaper to have a very good building shell and not to install a water heating inside the house. And we got the allowance to build a passive house. We, of course, were contacted every inhabitant. One of my office and one of the building firm were speaking, so we said we did know all the problems. That's, for example, the documentation of the closets, of the bathroom, and because it's very important, because behind there's also pumping. The strategy for renovation, and now you have learned already in the first part how we do it. You know this strategy already. It's a building. We take away the roof. It's bad insulated. We give a new roof also to get resources to do a very good renovation. It's done in wood because wood is not so heavy. A new elevators to give access to everyone to the building. Energy conservation by good windows in passive house quality, old ones, new ones. We close the balconies to have no thermal bridges, but to gain some energy, to have very high insulation, good details, and energy conservation by ventilation with controlled heat recovery. It's in the basement of this house, a central system, in, out of the air. Passive solar use, we come now to the productive part. Thermal collectors on the roof. Screens outside where it's necessary against the overheating in summer. And we have a central heating system with wood pellets. So the entire heat demand is covered without CO2 exhaustion. On the same site, there was also a reserve. We found out that it was possible to build also a new building. But what was very important is contact with people. So we were looking to other houses with this technology. We discussed it and we could convince them because it's the objective we are working for, people inside the house. The planning, the original planning, we had to convince everyone. There is also a meeting where the neighbors have their rights and they were against the building, but then we did overcome it and started to build. The house is on the roof and the new house. the roof construction with fire safetiness, the high insulation, organization of the people before giving away the old installation, the new installation with the new air ducts, and the result. The air ducts were just in the entrance hall. We didn't touch any room. There was just made to every room a hole, and the air is blown in. So people could keep all their things in their room, which was very convenient, and with this we could convince them. All the ducts are in the false roof in the entrance area. The collectors close to be finished. The result, there was a big festivity, so also the architect got some profit out of it. And the finished building with the air out in, and the new roof, which is very attractive. The new building has an elevator which gives access for the people in the old house. The air ducts outside, in this case, from the new building to the old one, and what it looks now. Before and after. An office building as example, it's very radical because it's a plus energy house. It's an office you also can drive with. We not offer just the energy for a house, we also offer the energy for their mobility. It's a special firm, it's like a grassroots firm, which had not just the objective to make money, they also want to have a social atmosphere, and they have a cultural obligation. It was a competition project, and interesting, already in the competition project, there were made evaluation for the life cycle cost or for the ecological quality over a long time. We orientated the building to a wind park these firms owns nearby, and it's an office building and a hall for repairing and storing things. And all the offices are oriented to the north, so that they don't heat to overheating, and all the communication areas to the south. Second floor, the building and the storage hall, and there's behind a strategy. So the architecture tries to be the same like the energy structure. You remember to this pyramid of the Mayas. It's a spinal inside a concrete wall to store energy, and all the rest is built out of wood. And the storage hall is completely made out of solid wood. There is also cotton used, clay for covering, and paper for insulation. It's done very much in communication with the owners. Energy conservation, done by paper. This wall is filled with paper. Heat recovering and ventilation of all the building. The PV is protecting against overheating. You see here ends the shadow. All the screens are in shadow. It's summer situation. Here we have inside shadow. Energy production, it's passive solar use. The sun can come in very well. It's a situation in winter where it's nice if you drink the coffee or you're communicating, you have the sun. There are thermal collectors integrated in the facade with a big storage tank, insulated with cotton again. There's PV, because the most demand in an office is electricity, not heat. There's all the roof covered with PV, and all the facade is covered with PV. It's a converter, and it gives a very nice shadow again. This shadow is moving through the hall like a sundial. And their cars are taking their energy from the building. Not any longer from somewhere else outside, it's own produced. In winter, in summer night, a very good ventilation. There are shutters, they open and give a good ventilation to the building. And to optimize this ventilation, we have wind generators on the roof. They are driven by the wind and they are sucking out so that we have a really very effective ventilation of this room. Also, the mechanical ventilation to save electricity has such a wind generator on the exhaust, and therefore, if there is wind, it's exhausting air, and the ventilation machine needs less energy. Water is taken out from the ground with this low-running windmill, and this low-running windmill is cooling the computer. The water goes to a tank and is used for the lawn or brought back. Coolness and heat is taken out from the earth by a lot of 100-meter deep drills, and we have a heater which brings up the energy to a higher level, this heat pump. Of course, we got some certification, and that's the result, the building of this firm, which is a very explicit expression and a very attractive facade. The storage hall, the north side, the south side, the rooms inside, all with very clean materials, the communication area, the break, and this attractive hall. And during night time, it communicates to the outside. What is the result? We have a monitoring now over 2 years, and you see that's the energy we are producing, that's the energy the building needs, and that's the additional energy for our production for the outside. It's for the computer, for the traffic, and for some additional electricity demand. And in the next year, they were buying more cars, and they need more energy here. But you see, with optimizing through monitoring, we are coming down with this demand. This is first year, second year, and we could optimize. And even if we take all the computers into account, we still can cover it. Or if we take all the mobility, we still have more production than the building and the mobility. And that's what it looks like. At least an example in a northern country, so that you have also a building which is built in an area like here in Stockholm. It's a special condition. It's comparing Vienna and climate in Estonia. So the project is here in Estonia. We are here in Stockholm, and I am coming from Vienna. It's more cold, it's a more heavy winter, but the same strategy, you know it, and also productivity, because the challenge was to get a house which is producing the same energy which is using. Is this possible or not, even in a northern country? That was a challenge. And here we have the production, and here we have the consumption. Yes, it's possible. We drilled deep holes. It's built out of wood. It's a lot of detailing. It's the studies of every detail to calculate it. It's filled again with paper chips. It's built out of clay additionally to have storage mass. It has its ventilation system with heat control. Here is the exchanger. It has thermal collectors, vertical, because the sun is very much down in this area in winter, but there are also some thermal collectors on the roof. And we are taking out from the ground the energy, and the PV is suspended so that the snow doesn't stay on it, and it's completely without shadow. for the PV, but the VP is used to give the building a dynamic, a moving shadow. We get some certifications, and that's the building. It's in summer closed, in winter open. It's a sauna, which has a look to the outside with a very good window. From above. And it's a little bit what we need in architecture, like with the planes. The planes are optimized. Some of the new planes, if you go with first class, you even get ecological food in those planes. Is it a ecological way to travel if you get eco food? No, it's by far not. They are using less petrol. It's technically optimized, but it's the same technology. And I think an alternative in flying could be to optimize, but it's still the same technology. It's very light, it's using photovoltaic. But I think we need a new thinking. Like this one is another way of aircraft, it's another way of plane, which is a different way of thinking. And I think it's the same in architecture, that we have to think out a new way of architecture. And I am curious to hear your questions and to go into discussion with you. I'm waiting for your response. Thank you very much for listening.